Today, we'll talk about a very popular vertical lookup formula in Google Sheets, VLOOKUP. It is frequently used by office employees in marketing, sales, and analytics departments, among others. This formula is great for pulling data from another table based on an identifier, such as an article number or name. For example, let's say you work in the sales department and have a table with stock levels for different items. You want to check monthly sales for these items from another table and compare them with the stock. The VLOOKUP formula helps you do this quickly. Now, let's break down what this formula consists of, how it works, what to pay attention to, and which mistakes to avoid to ensure it works correctly. We have two sheets in a Google Sheets file. The first sheet is called Price List, where we have fruit prices. The second sheet is called Orders, containing the same fruits. Note that they appear in a different order, and bananas are listed twice, but without prices. Instead, it has columns for quantity and total cost. The total cost is calculated by multiplying the price by the quantity. Currently, since the price column is empty, the total cost is 0. We need to retrieve the price to calculate the total cost. In this example, there are only a few items, so it would be easy to do manually, but imagine if the orders column had a large amount of data with many different people ordering the same fruit in various quantities. Doing this manually would take a lot of time and could lead to errors. This is where VLOOKUP comes in. Let's enter the formula in cell C3. First, click on the question mark icon to review the function's arguments. VLOOKUP takes 4 arguments. Search key, the identifier we are searching for, which must exist in both tables. In our case, this is the fruit name. The search key is a single value and must match the data type in the first column of your range. Range, the data range where we will search. It is important to lock the range using the $sign to prevent shifting, and also to ensure that the search key is in the first column of the selected range. Note that column headers should not be included in the range. In our case, the range is A2 to B5. Index, the column number from which we need to retrieve values. In our example, this is column 2 from the price list sheet. Is sorted, this argument can be true or false. False means an exact match is required. If we search for apple, the function will only return a value for apple. If there is a typo, such as app, the result will be an error not available. True performs an approximate search and works best for numeric identifiers. It requires the lookup table to be sorted in ascending order, or alphabetically for text. If the exact value isn't found, it returns the closest, smaller, or equal value. For example, if you have a table with tax rates for different income levels and your income does not exactly match any number in the table, using true will allow you to get the correct tax rate even without an exact match. True is most commonly used when the identifier is a number. In our case, we will set it to false, as we need an exact match. Now that we understand the function, let's enter it in the sheet and drag it down. As we can see, the prices have appeared, and the total costs have been calculated. To make our formula more readable, we can assign a name to our range. Open the price list sheet. Select the range. By the way, the $sign is not needed here since the range is automatically fixed. Click the drop-down arrow in the top left corner and select Manage Named Ranges. In the right panel, enter Fruit Prices. Use an underscore instead of a space. Click Done. Now, instead of specifying a range in the formula, we can use the named range. Start typing the name and Google Sheets will suggest it automatically. After updating the formula, drag it down again. This makes it clearer where the data is coming from. Sometimes we might get "not available" error, indicating that a value was not found. Let's simulate an error by removing the banana from the first table. To do this, we will use the if-NA function. First, let's check its arguments. We can see that it takes a value and a text that will be used in case of an error. The value is what the VLOOKUP function returns in our case, and for the text, we can write "not found." Now, let's apply the function and drag it down. Instead of an error in the price column, we now see our custom text. However, in the total column, we now get a calculation error because text cannot be multiplied by a number. To fix this, we can use if error, which works similarly to if-NA. We replace errors with a meaningful message like "item does not have a price." After applying if error, we drag the formula down again. Now, let's add banana back to the price list. And everything works correctly again. That's it. We have explored the VLOOKUP function. Many people talk about it, but as you can see, it's not complicated at all. Thank you for watching. See you in future videos. Let us know in the comments what other functions you'd like us to cover, or what questions you have, and we'll take a look at them.